Okay, so we're going to talk about accuracy and precision. Most people get these two confused. They're not the same thing. There are a difference between the two, and that's what we're going to look at today. Also, we're going to look at percent error towards the end of this presentation. So let's get started. So accuracy is how close a measured value is to an actual value. So down below you'll see two targets. Now they both show some type of accuracy, because with a target you want to hit the bullseye. That's going to be your actual value. So in the left picture you'll see all the little black dots are your hits, and they're all in the center, the bullseye, and they're the closest. And in this case we're going to call it high accuracy. Now looking at the target on the right, you see all the hits are close to the bullseye. So it is still accurate, but they're not quite on the bullseye. They're a little bit more spread apart. So in this case, we would describe it as a low accuracy. Okay, they're still close, but they're not quite on the bullseye. But how does this look when we take actual values, numbers that we measure? So if you look, I have this 1 kilogram weight. Now, if I were to weigh it 3 times on a scale and I get numbers as 1.1 kilograms, 1.2 kilograms, and 1.0 kilograms. So looking at those, they're all close to 1, but they're just a little bit off. There's 1.1 and 0.2. So this is still accuracy, and this would be your high accuracy measurements. After looking at accuracy, now we move to precision. This is just how close the measured values are close to each other. This is regardless of the actual value. You're just looking to see if your values are close to each other. Now looking at the two targets below, you'll notice that you have both precise targets. All the hits are somewhat close together. But how close, you can look on the left, all the dots are really packed together. So we would say this is high precision. There we go. Precision. But the one on the right has, the dots are close together, but they're not as packed in. So we would say it's just low precision. Now how this would look with numbers, I still have my 1 kilogram weight. So if I get a reading of 1 kilogram, and you see that the actual value is still 1 kilogram, but regardless of that, all of them are really are the same number, so they're really packed in. So this would be a very precise measurement. Okay, just looking at these targets, now we're going to add accuracy and precision together and how we can describe these hits on these targets. So you'll notice this first one right here is high accuracy and high precision. All the hits are on the bullseye, the actual value, and they're really packed in the center. So that is both high accuracy and high precision. Now as you go down the list, you can see examples of where one thing may be a low accuracy, but it's still high precision, or something could be very accurate or high accuracy, but still low precision. And at the very bottom here, you can see where they're low accuracy and low precision, where you notice all the hits are all over the place and they're not anywhere near close to each other or near that actual value. But it's nice to look at these targets, but how does it actually look when we look at numbers and measurements? So say I was measuring something, and the true value is going to be 5 kilograms, or I'm sorry, 5 grams. So looking at this first set on the left, you'll see that I get a value of 4.9 grams, 5.0 grams, and 5.1 grams. Well, since the true value was 5 grams, well, it's very close to being, it's very close as far as accuracy goes, because it's really close to the true value. So I would say that's high accuracy. Now looking at precision wise, it's just how close that each one of these numbers are together. So they're very close to each other, only 1/10 off from each other, so this would be actually high precision. Now if you look on the right, I have these values, 4.2 grams, 4.3 grams, and 4.2 grams. So looking at accuracy, well, my true value was 5. These are actually quite low. They're nowhere close to the 5 grams. So this would be actually low accuracy. But looking at the numbers together, I noticed that they're really close apart, because I got 2 4.2 and 1 just slightly higher than that. So actually this is going to be a high precision. So that's looking at accuracy and precision and how we use them in science, because when we do experiments, we want to make sure that we get the very high accurate and high precise numbers, because if we don't, it can make our readings or our findings misleading, and we don't want that. Now we have something called percent error. This is just comparing our experimental values or calculated values with established accepted values. And there's an actual formula we use. So if you look right here, we have percent error, but we're going to take our experimental value, subtract it to from our accepted value, and divide it into accepted value. But if you notice these bars right here, and if you remember in math what those actually are, they're called absolute value. That means any number that comes in between those bars is going to be a positive number. And then whatever you get that number, it's going to be positive, and you just multiply it by 100 to get a percent. So on the next slide, we're going to do an example. So I calculated density of silver at 9.59 grams per centimeter cube. The accepted value is 10.49 grams per centimeter cube. So I need to calculate the percent error, or how much am I off from the accepted value. So just going by, I just fill in the information. My experimental value would be my calculated value. So it's 9.59. I'm going to subtract it from the accepted value, 10.49, and then I'm going to divide it into the accepted value again. When I do that, so I will take 9.59, subtract 10.49, and divide it into 10.49. And I get something like 0.085, but it's negative. Well, remember the absolute value is in there, so any number that comes out is going to be positive, so that negative doesn't really need to be there. And all we're going to do next is just multiply it by 100. So I'll take the 0.085 and multiply it by 100. So its total answer is going to be 8.5%. So between when I'm comparing it, I'm only off by 8.5%.